Hello, in this lecture we will answer on two questions. The first question is to find out the side length of this square ABCD, and the second question will find out the length of side AD that is equal to x. Okay, so we start with the first question. In the drawing we have square ABCD. We know that line segment DE equals to 2 units, and we also know that the radius of this circle is equal, actually line segment DE equals to 1 unit, and the radius of this circle equals to 2 units. So we want to find out the length of one side of square ABCD. So we define the center of this circle as point O. We define the point of tendency of tangent AD with this circle as point M. And we will join points O and M together by a straight line. So O is the center of the circle, M is a point on the circle itself. That is to say, MO is the radius of this circle. So we define the radius of this circle as R, and it is given us the question that R equals to 2 units. Okay, so here we have the radius of this circle that is drawn to the point of tendency. That is to say, it is drawn to point M, that is the point of tendency of tangent AD with this circle. And whenever you have a radius that is drawn to the point of tendency, then the tangent AD will be perpendicular to the radius MO. So AD is perpendicular to MO. That is to say, this angle equals to 90 degrees, and this angle will be equal to 90 degrees. Okay? We will define the point of tendency of tangent AB with this circle as point L, and we will join points O and L together by a straight line. Here, line segment LO is the radius of this circle because of the fact that line segment LO starts from point O, that is the center of the circle, and ends at point L, that is the point on the circle itself. So OL is the radius of this circle that is equal to R, and R equals to 2 units according to what is given us the question. And again, we have the radius OL that is drawn to the point of tendency. That is to say, the radius OL is drawn to point L, that is the point of tendency of tangent AB with this circle. And whenever we have a radius that is drawn to the point of tendency, then the tangent AB will be perpendicular to the radius LO. So if AB is perpendicular to LO, it means that this angle equals to 90 degrees, and this angle will be also equal to 90 degrees. And we also know that quadrilateral ABCD is a square, and all the angles inside a square are right angles. That is to say, angle PAD equals to 90 degrees because it is 1 out of 4 angles of square ABCD. Therefore, it is a right angle. So actually, in quadrilateral OMAL, we have 1, 2, 3 right angles. So write it down. In quadrilateral OMAL, we have 3 right angles, and the sum of right angles is 90 times 3, that is equal to 270 degrees, plus the size of the fourth angle, that is actually angle MOL, this angle. In total, the sum of those four angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Okay, again, we got the equation. Then 270 degrees plus angle MOL equals to 360 degrees. Here we subtract 270 degrees from this equation, and we will get that the missing angle MOL equals to 360 degrees minus 270 degrees, it is equal to 90 degrees. Okay, so angle MOL equals to 90 degrees. It is a right angle, and so this angle is a right angle, it is equal to 90 degrees. Actually, we found out that all the angles inside quadrilateral MOAL are right angles, so quadrilateral MOAL has 4 right angles, and any quadrilateral that has 4 right angles must be at least a rectangle. So we will relate to quadrilateral MOAL as a rectangle. It's at least a rectangle, if not a square, so we relate to it as a rectangle. So we actually found out that quadrilateral MOAL is a rectangle, and we know that the opposite sides of a rectangle are equal to each other. That is to say, MO equals to AL. In rectangle MOAL, MO equals to AL. MO equals to AL. Okay, according to the rule that the opposite sides of a rectangle are equal to each other, we get that MO equals to AL. But MO equals to 2 units. We already found out that MO equals to 2 units, so we can write down that MO equals to 2 units. MO equals to 2 units, and from this equation 2 equals to MO equals to AL, we will derive that AL is also equals to 2 units. AL is also equals to 2 units. Likewise, in rectangle MOAL, OL must be equal to MA. OL must be equal to MA. OL must be equal to MA, according to the rule that the opposite sides of a rectangle are equal to each other. We get that OL equals to MA, but we have already found out that OL equals to 2 units, so we can write here that OL equals to 2 units. And from this equation, 2 equals to OL equals to MA, we derive that MA is also equals to 2 units. MA is also equals to 2 units. So here, MA equals to 2 units. We have already found out that AL is also equals to 2 units. From here, AL also equals to 2 units, and MA is also equals to 2 units. So actually we found out that quadrilateral MOAL is not a rectangle but a square. Quadrilateral MOAL is a square. Okay. In the next step we will define one side of square ABCD as x. So here we will get that AB equals to BC equals to CD and equals to AD, and all those sides of square ABCD, they are equal to x according to our definition. So here AB equals to BC equals to CD equals to AD equals to x according to our definition. And in the next step I will present to you rule number 2 that I already presented to you in the past. According to rule number 2, the lengths of two tangents from a common external point to a circle are equal. Okay, the lengths of two tangents from a common external point to a circle are equal. This is rule number 2 that I have already mentioned to you in the past. So we will implement rule number 2 in our drawing. We will focus on the common external point, point E. This is point E. So at point E, from the common external point, point E, we have two tangents to this circle. From this point, point E, we have two tangents to this circle. The first tangent is tangent EM, and the second tangent is this tangent. So we define the point of tendency of tangent EB with this circle as H. So the second tangent is tangent EH. And according to rule number 2, the lengths of those two tangents are equal to each other. That is to say, tangent EM equals to tangent EH, because both of them exited from point E. Therefore, EM equals to EH according to rule number 2. And what is the length of tangent EM? From the drawing you can see that the length of tangent EM is actually equals to AD minus DE minus MA. I repeat again, the length of tangent EM is equal to AD minus DE minus MA. So EM equals to AD equals to x according to our definition, minus DE equals to 1 unit according to what is given us in the question, and we have already found out that MA equals to 2 units. So actually, in conclusion, we found out that EM equals to x minus 1 minus 2. X minus 1 minus 2 equals to x minus 3. So in conclusion, we found out that EM equals to x minus 3 units. EM equals to x minus 3 units. We can write here that EM equals to x minus 3 units, and according to rule number 2, EM equals to EH. I repeat again, we already found out that EM equals to EH according to rule number 2. But we just right now found out that EM equals to x minus 3. EM equals to x minus 3. And from this equation, x minus 3 equals to em equals to eh. We will derive that eh is also equals to x minus 3. Eh equals to x minus 3 also. So here, eh equals to x minus 3. Here we can write that EH equals also to x minus 3. In the next step, we will focus on the external point B. On the external point B, from the external point B, we have two tangents to the circle. Here, from the external point B, we have two tangents to this circle. The first tangent is tangent BL, and the second tangent is tangent BH. And according to rule number 2, the length of those two tangents that are exiting from the common external point B are equal to each other. That is to say, BL equals to BH according to rule number 2. And what is the length of BL? BL, from the drawing, it is very easy to see that BL equals to AB minus AL. AB minus AL equals to BL. Again, BL equals to AB minus AL. So BL equals to AB. AB equals to X according to our definition. And AL equals to 2 units according to what we have already found out. So in conclusion, we found out that BL equals to X minus 2. Okay, BL equals to X minus 2. So we can write here that BL equals to X minus 2. And LB equals to X minus 2. And we have already found out that BL equals to BH according to rule number 2. But we just right now found out that BL equals to X minus 2. So we can write here that BL equals to X minus 2. And from this equation, X minus 2 equals to BL equals to BH, we will derive that BH is also equals to X minus 2. BH is also equals to X minus 2. We can write here that BH equals to X minus 2. Okay? So actually, we know that triangle DAB is a right triangle because triangle EAB, this triangle EAB is a right triangle because angle EAB equals to 90 degrees. So we will implement the Pythagoras theorem on the right triangle, triangle EAB. We know that AB equals to X according to our definition. What is the length of side A and E? From the drawing, you can see that AE equals to AD minus DE. I'll repeat again. AE equals to AD minus DE. You can see it from the drawing, from the original drawing. So AE equals to AD, that is X, according to our definition, AD equals to X, minus DE, that is equal to 1, according to what is given as the question. So in conclusion, we found out that AE equals to X minus 1. And here, AE equals to X minus 1. So we can write here that A equals to X minus 1. And what is the length of the hypotenuse EB? The length of the hypotenuse EB is very easy to see from the drawing that EB equals to X minus 3 plus X minus 2. Okay, I'll repeat again. The hypotenuse, the length of the hypotenuse EB is equal to X minus 3 plus X minus 2. X plus X is 2X. And minus 3 plus minus 2 is minus 5. So in conclusion, we found out that EB equals to 2X minus 5. EB equals to 2X minus 5. I'll repeat again. The hypotenuse EB equals to 2X minus 5. Now we implement the Pythagoras theorem. PT is the abbreviation of Pythagoras theorem. On the right triangle, triangle AEB. So according to the Pythagoras theorem, this will be equation number 1. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is EB, therefore the square of the hypotenuse is EB squared. And it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to AE squared plus AB squared. So here we'll substitute EB by 2X minus 5. Therefore, EB squared will be equal to 2X minus 5 squared. And it is equal to AE. We'll substitute AE by X minus 1. So if A equals to X minus 1, then AE squared will be equal to X minus 1 squared plus AB squared. AB equals to X, so AB squared will be equal to X squared. So in conclusion, we found out that according to equation number 1, 2X minus 5 squared equals to X minus 1 squared plus X squared. Here we will open the brackets on both sides of this equation. Equation number 1, according to the algebraic identity, that A minus B squared equals to A squared plus B squared minus 2 times AB. And we get here that 2X minus 5 squared equals to A squared, that is 2X squared, that is 4X squared, plus B squared, that is plus 5 squared, that is 25, minus 2AB, it is minus 2 times 2X times 5, that is minus 20X. And it is equal to X minus 1 squared, it is equal to X squared, plus 1 squared, that is 1, minus 2X, plus X squared. So we get that according to equation number 1, we actually found out that 4X squared plus 25 minus 20x equals to x squared plus x squared is 2x squared minus 2x plus 1. Okay, so this is equation number 1. We will subtract 1 from this equation number 1, so we get that 1 minus 1 is 0, 25 minus 1 is 24. We'll subtract 2x squared from this equation number 1. 2x squared is 0, 4x squared minus 2x squared is 2x squared. And we will add 2x to this equation number 1. 2x minus 2x is 0. And minus 20x plus 2x is minus 18x. So in conclusion, we found out that according to equation number 1, 2x squared minus 18x plus 24 equals to 0. We'll divide this quadratic equation by 2 and we'll get that according to equation number 1, 2x squared over 2 is x squared, minus 18x over 2 is minus 9x, and 24 over 2 is 12. 0 over 2 is 0. So in conclusion, we got the quadratic equation that x squared minus x squared minus 9x plus 12 equals to 0. In this quadratic equation, the coefficient a equals to 1. The coefficient b equals to minus 9, and the coefficient c equals to 12. The variable that we're looking for is x, and we'll find out the value of x according to the special formula for finding out the value of x. Here x equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. Okay. Here a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. So we'll put the data inside the formula in order to find out the value of the values of x. We get that x equals to minus b equals to minus 9, so minus b is minus 9, that is 9 plus minus square root of b squared. B equals to minus 9, so b squared is minus 9 squared, that is 81. Minus 4 times a is 1 times c is 12 over 2a. A is 1, so 2 times 1 is 2. So here we get that x equals to 9 plus minus square root of 81. Minus 4 times 12 is minus 48 over 2. So here x equals to 9 plus minus, inside the root we have 81 minus 48 is 33, so inside the root what is left is only 33 over 2. So here we will have two solutions that are possible for x. The first solution for x is that x equals to 9 plus minus square root of 9 minus 9 minus, the first solution is 9 minus square root of 33 over 2. 9 minus square root of 33 over 2 is 1.62 units. So we found out that x equals to 1.62 units. Okay, so here actually, according to our definition, AB equals to x. And according to the first solution, x equals to 1.62. But x can never be equal to 1.62. Why? Because x equals to AB, and AB is larger than AL, that is equal to 2 units. So here, AB that is equal to x it must be greater than 2 units, because you can see here that AB is greater than AL. AB is greater than AL, and AL is equal to 2. That is to say, AB must be greater than 2. That is to say, x that is equal to AB must be greater than 2 units. Okay, x must be greater than 2 units, and 1.62 is less than 2 units. Therefore, this solution is incorrect solution. We cancel the solution, and only the second solution left, that is x equals to 9 plus square root of 33 over 2. That is actually equals to about 7.37. 7.37. So we found out actually that all the sides of square ABCD, they are equal either to 7.37 units, or we can present it also as 9 plus square root of 33 over 2, that is equal to 7.37 units. Okay, we finished with the first question. In the next step, I will present to you the second question, and we will solve the second question in 2 different methods. Okay, so in the drawing we have triangle ABC. This is triangle ABC. We know that side AB equals to A units, side AC equals to 2 units, side BD equals to 2 units, angle BAD equals to angle DAC, and both of those angles are equal to 60 degrees, and we want to find out the length of side AD that is equal to x, according to what is given as the question. Okay? So first of all, I will present to you the angle bisector theorem, and we will implement the angle bisector theorem in this triangle ABC. So what is the angle bisector theorem? Here. The angle bisector theorem is true in any triangle. So here we have triangle ABC. That could be any triangle. This is triangle ABC. Here AD, line segment AD is angle bisector. Why line segment AD is angle bisector? Because of the fact that line segment AD bisects angle BAC into two halves. Each half equals to theta. Therefore AD is an angle bisector. According to angle bisector theorem, we get that AB over AC equals to BD over DC. Okay? Whenever we have a triangle ABC that could be any triangle, and in this triangle we have the angle bisector, then according to angle bisector theorem, we get that AB over AC equals to BD over DC. We will implement the angle bisector theorem in our original drawing in triangle ABC. So according to angle bisector theorem, we get here that AB over AC AB over AC must be equal to BD over DC. I'll repeat again. In triangle ABC, according to angle bisector, we know that AD, I repeat again, we know that AD is angle bisector. AD is angle bisector. Why AD is angle bisector? Because of the fact that line segment AD bisects angle BAC into two halves. Each half equals to 60 degrees. Therefore AD is an angle bisector, so we can implement the angle bisector theorem in this triangle, triangle ABC, because it has the angle bisector AD. And according to angle bisector theorem, we get that AB over AC equals to BD over DC. So here, according to what is given as the question, AB equals to A, so we substitute AB by A. And according to what is given as the question, AC equals to 2A, we'll substitute AC by 2A, and it is equal to BD. BD equals to 2 units. So we'll substitute BD by 2 units over DC. DC is the missing line segment, so we leave it as it is. So in conclusion, we found out that according to equation number 1, A over 2A equals to 2 over DC. A over A is 1, so A will get cancelled. A will get cancelled, and we're left with only 1 half. That is equal to 2 over DC. Here we will cross multiply this equation, equation number 1, and we get that according to equation number 1, DC equals to 2 times 2, that is to say, DC equals to 4 units. Okay, so here we can write down that DC equals to 4 units. In the next step, we will do a construction. First of all, we will extend side AC of triangle ABC by a straight line. So we'll extend side AC by a straight line. And after we extended side AC by a straight line, from point B, we will draw perpendicular to the extended side AC. Okay, again from point B, we will draw perpendicular to the extended side AC. That is to say, so here this angle equals to 90 degrees according to our construction. Okay, again this angle equals to 90 degrees according to our construction. We'll define the touching point we'll define the touching point of the extended side AC and the perpendicular from point B as E. Okay, so actually AC is one side of triangle ABC, therefore it is absolutely a straight line. AC is a side of triangle ABC, it must be a straight line. And when we extended the straight line AC by a straight line, the result must be a straight line. So by extending the straight line AC by a straight line, we got the straight line EC. The straight line EC must be also a straight line. Why? Because when you extend a straight line by a straight line, the result must be a straight line. Okay? So we can write down that CE is a straight line. CE is a straight line. C is a straight line. And we have the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. I repeat on the rule. According to the rule that I mentioned, the sum of the angles on one side of a straight line is equal to 180 degrees. We actually arrived to the conclusion that CE is a straight line. Therefore, we can implement the rule that I mentioned on the straight line CE. So if we focus on this side with the straight line CE at point A, then the sum of the angles must be equal, the sum of the angles here at point A and this side of EC must be equal to 180 degrees according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at point A? At the lower side of the straight line EC, we have here 60 degrees plus 60 degrees plus this angle that is actually angle EAB. In total, the sum of those three angles must be equal to 180 degrees according to the rule that I mentioned, that the sum of the angles on one side of a straight line is equal to 180 degrees. Okay, here 60 degrees plus 60 degrees is 180 degrees. 120 degrees. 60 degrees plus 60 degrees is 120 degrees, so we subtract 120 degrees from this equation, and we get that the missing angle EAB equals to 180 degrees minus 120 degrees, it is 60 degrees. So we found out that the missing angle EAB equals to 60 degrees. So can I write down here that this angle equals to 60 degrees. In the next step, we will focus on the right green triangle, triangle EAB. On the right green triangle, triangle EAB, we know that cosine 60 degrees equals to, here, this is the angle of 60 degrees, so cosine 60 degrees equals to EA over the hypotenuse AB. EA over the hypotenuse AB. So it is equal to EA over AB, but AB equals to A according to what is given as the question. So we substitute AB by A. So we found out that cosine 60 degrees equals to EA over A. We will multiply this equation by A, and we will get that EA equals to A times cosine 60 degrees, and cosine 60 degrees is 1/2. So we substitute cosine 60 degrees by 1/2, and we will get that EA equals to A times 1/2, so A over 2. So we found out that EA equals to A over 2. You can write here that EA equals to A over 2. We also continue to focus on the right triangle, triangle EAB. On the right triangle, triangle EAB, we know that sinus 60 degrees, here sinus 60 degrees equals to EB over BA. EB over BA sinus 60 degrees is square of 3 over 2, so we substitute sinus 60 degrees by square root of 3 over 2, and it is equal to EB over BA. BA equals to A according to what is given as the question, so we'll substitute BA by A, and we'll get that square root of 3 over 2 equals to EB over A. We'll multiply this equation by A, and we'll get that EB equals to square root of 3 over 2 times A. EB equals to square root of 3 over 2 times A. You can write here that EB equals to square root of 3 over 2 times A. Okay. In the next step, we will implement the Pythagoras theorem on the big right triangle, triangle EBA. So I'll copy the right triangle EBA in a new page and we will implement the Pythagoras theorem on the right triangle. Actually, it is triangle EBC. EBC is the right triangle, so we'll implement the Pythagoras theorem on the right triangle, triangle EBC. So I'll copy the right triangle EBC. The new page. E, B, C. We have already found out that side EB equals to square root of 3 over 2 times A. What is the length of side EC? EC equals to 2A plus A over 2 again. EC equals to 2A plus A over 2. 2A plus A over 2 is 2.5A. And 2.5A is 5 over 2A. What is the length of the hypotenuse BC? BC equals to 2 plus 4, that is 6. So in the right triangle, triangle EBC, by PT is the relation for Pythagoras theorem. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, the hypotenuse is BC, therefore the square of the hypotenuse is BC square, and it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to BE square plus EC square. So according to we found out that BC square equals to BE square plus EC square. BC equals to 6, so BC square is 6 squared, that is 36, and it is equal to BE square. BE equals to square root of 3 over 2, so BE square is square root of 3 over 2 squared. Square root of 3 over 2 times A, of course, square, plus EC square. EC equals to 5 over 2 times A, or 5 halves times A. So EC square will be equal to 5 halves times A square. So here we will open the brackets on this side of equation number 2, and we get that we have, on this side we have 36, that is equal to square root of 3 square is 3, 2 square is 4, and A times A is A square. So in conclusion, this expression equals to 3/4 times A square plus 5 over 2 times a squared is 5 squared is 25 over 2 squared is 4 times a is a squared. So according to question number 2, we found out that 36 equals to, we have 3 quarters plus 25 quarters. 3 quarters plus 25 quarters is 28 quarters times a square, of course, and 28 over 4 is 7. So 36 equals to 7 times a square. We'll divide this equation number 2 by 7, and we'll get that a square equals to 36 over 7. Here we take a root out of this equation number 2, and we'll get that a equals to the square root of 36 is 6 over square root of 7. In conclusion, we found out that a equals to 6 over square root of 7. In the next step, I will present to you a new rule that is actually rule number 3, that is related to the angle bisector in a triangle. According to rule number 3, if we have triangle ABC that could be any triangle, this is triangle ABC. In triangle ABC we have the angle bisector AD. AD is angle bisector. AD is angle bisector. I'll write it down. Because it bisects angle BAC into 2 halves, each half equals to theta. Therefore AD is angle bisector. According to rule number 3, we will get that AD squared equals to AB times AC times BD minus BD times DC. I repeat again, if we have triangle ABC that could be any triangle, and inside triangle ABC we have the angle bisector AD, then according to rule number 3 we'll get that AD squared, that is actually the angle bisector squared, it is equal to AB times AC minus BD times DC. Okay, so here we will implement the angle bisector rule number 3 in triangle ABC. So actually, this is triangle ABC. Side AC equals to 2A according to what is given us in the question. Side AB equals to A according to what is given us in the question. We have already found out that BC equals to 2 plus 4, that is 6. No, here we actually don't need it. This is the angle bisector AD that is equal to X. BD equals to 2 units, and we already found out that DC equals to 4 units. So we'll implement the angle bisector theorem on this triangle ABC. This is not angle bisector theorem, but rule number 3. According to rule number 3, we get that AD squared equals to AB times AC minus BD times DC. Okay, repeat again. We implemented diagonal circle. We implemented rule number 3 in this triangle, triangle ABC, that I copied from the original drawing. According to rule number 3, we'll get that AD squared equals to AB times AC minus BD times DC. So here we have question number 3. Coming to question number 3, AD equals to x, so AD squared is x squared, and it is equal to AB equals to A, times AC is 2A, minus BD is 2, this is 4. 2 times 4 is 8. So in conclusion, we found out that according to question number 3, x squared equals to A times 2A is 2A squared minus 8. So according to equation number 3, we found out that x squared equals to 2. And we already found out that A squared equals to 36 over 7. So we substitute A squared by 36 over 7 minus 8. So x squared equals to 2 times 36 is 72 over 7. We multiply 8 by 7 and then we divide it by 7 in order to have a common factor with this expression. Minus 8 times 7 is minus 56. And here 72 minus 56 is 16 over 7. So we found out that actually x squared equals to 16 over 7 according to equation number 3. Here we take a root out of this equation, equation number 3, and we get that x equals to square root of 16 is 4 over square root of 7. So we found out that x equals to 4 over square root of 7, or in terms of numbers it is equal to 1.51 units. Okay, so right here that here x equals to this line segment x, it is actually also equals to AD, it is equal to either 4 over square root of 7 units, or in terms of numbers it is equal to 1.51 units. We finish with the first method. In the next step I present to you how to find out the length of line segment AD that is equal to x according to the second method. Okay. In the second method, we define angle ADB as theta. We know that BC is a straight line, and therefore if angle ADB equals to theta, it means that angle ADC must be equal to 180 degrees minus theta. In the next step I will present to you the law of sines. according to the law of sines, according to the law of sines, first of all, the law of sines is true in any triangle. So if we have triangle ABC, that could be any triangle. Side BC of triangle ABC equals to A units in its length, side AC equals to B units in its length, and side AB equals to C units in its length. Then according to the law of sines, we get that A over sinus A, capital A is the length, is the size of angle BAC. So A over sinus A equals to B over sin B. Again, capital B is the size of this angle, angle ABC. It is equal to C over sinus C. Okay, we can implement the law of sines in any triangle. So repeat again, A over sin A equals to B over sin B equals to C over sin C. So we will implement the law of sines in triangle ABD. In triangle ABD, according to the law of sines, we'll get that A over sin theta must be equal to 2 over sinus 60 degrees Now we will implement the law of sines in this triangle, triangle ADC. This will be question number 2. Here we'll get that CD over sine 60 degrees equals to 2a over sinus 180 degrees minus theta. And we have the trigonometric identity that states that sinus 180 degrees minus theta equals to sinus theta. So according to this trigonometric identity, we can substitute sinus 180 degrees minus theta in this equation number 2 by sin theta. We'll do it now and we'll get that according to equation number 2. CD over sinus 60 degrees equals to 2a over sinus theta. Substitute sinus 180 degrees minus sinus theta. So here we have the expression of a over sinus theta, and according to equation number 1, a over sinus theta equals to 2 over sinus 60 degrees. So we can substitute a over sinus theta in equation number 2 by 2 over sinus 60 degrees from equation number 1. So we'll do it now, and we'll get it according to equation number 2. CD over sinus 60 degrees equals to 2, and A over sinus theta, according to equation number 1, equals to 2 over sinus 60 degrees. So we found out that according to equation number 2, CD over sinus 60 degrees equals to 2 times 2 over sinus 60 degrees. We have sinus 60 degrees on both sides of equation number 2, so sinus 60 degrees will get cancelled. And according to equation number 2, we found out that CD equals to 2 times 2, so CD equals to 2 times 2, that is 4. So we found out that CD equals to 4 units, exactly as we found out in the first method. In the next step, I will present to you the law of cosines, and we will implement the law of cosines in triangle ABC. The law of cosines is true in any triangle. So if we have triangle ABC, that could be any triangle. This is triangle ABC. This is angle theta. The length of side BC is equal to C units in its length. Side AB equals to A units in its length, and side AC equals to B units in its length. Then, according to the law of cosines, we will get that cosine theta equals to A square plus B square minus C square over 2 times AB. Okay, it is true in any triangle. So we can implement the law of cosines in our triangle ABC. Okay, so =60 degrees plus 60 degrees is 120 degrees. So actually I will copy triangle ABC this page, and we will implement the law of cosines in this triangle, triangle ABC. This is triangle ABC. We know that angle BAC, this angle equals to 180 degrees. AB equals to A, according to what's given in the question. AC equals to 2A, and we have already found out that BC, sine BC equals to 2 plus 4 is 6. So according to the law of cosines, we will get that cosine 120 degrees equals to AB square is A square plus AC square is 2A squared, that is 4A squared, minus BC square is minus 6 squared, that is 36, over 2 times AB is A, times AC is 2A. Okay, so this equation is the implementation of the law of cosines in triangle ABC. We know that cosine 120 degrees equals to minus 1/2, and it is equal to A square plus 4A square is 5A square minus 36 over 2A times 2A. Here we have 2 on both sides of the equation, so 2 will get cancelled. In the next step, we will cross multiply this equation, this equation. Okay. Will be actually equation number 3. So we'll cross multiply this equation, equation number 3. In the denominator we have A times 2A is 2A squared. 2A squared times minus 1 is minus 2A squared. Minus 2A squared is equal to 5A squared minus 36. Here we will add 2A squared and also 36 simultaneously to this equation, equation number 3, and we get that according to equation number 3, (7A squared) equals to 36. We divide this equation, equation number 3, by 7, and we'll get that according to equation number 3, A squared equals to 36 over 7. We take out of this equation, equation number 3, and we'll get that A equals to a square root of 36, that is 6 over square root of 7. So we found out that A equals to 6 over square root of 7 units. In the next step, I will present to you a new way to calculate the area of any triangle. Okay, so if we have a triangle ABC, that will be any triangle. This is triangle ABC. This is angle theta. The length of side AB is A units. Side AC equals to B units in its length. So the area of this triangle ABC will be equal to A times B times sinus theta over 2. Okay? We'll use the formula for the area of a triangle in our drawing. In our drawing, the big triangle ABC consists from two small triangles. It is very obvious from the drawing that the sum of the area of triangle ABD plus the sum of the area of triangle ADC, in total the sum of those two areas, it will be equal to the area of the big triangle ABC. It's very obvious from the drawing. So I write it down from the drawing. It is very easy to see that the area of the big triangle ABC is equal to the area of triangle ABD plus the area of triangle ADC. According to the formula that I presented to you, the area of triangle ABC will be equal to A times 2A times the angle, this angle that is 60 plus 60 is 220 degrees times sinus 220 degrees over 2. So this is the area of triangle ABC. We'll calculate the area of triangle ABC according to the new formula. The area of triangle ABD will be equal to A times X times sinus 60 degrees over 2 plus the area of triangle ADC. The area of triangle ADC is equal to X times 2A times sinus 60 degrees over 2. So here we have 2 on both sides of the equations in the denominator, so 2 will get cancelled. We also know that sinus 120 degrees equals to sinus 60 degrees, so we can divide this equation by sinus 60 degrees. And we'll divide this equation also by A, because we have A on both sides of the equation. So here A will get cancelled, and A also will get cancelled. So what is left after we cancel all the variables? Here we have 2A that is equal to X plus 2X. So we found out that 2A equals to X plus 2X, that is 3X. We divide this equation by 3 and we get that X equals to 2 over 3 times A. But we have already found out that X equals to 2 over 3 times A, but we have already found out that A equals to 6 over 7, so 6 over square root of 7 units, so we substitute A by 6 over square root of 7 units. Okay, so here 6 over 3 is 2, so it is 2 times 2 over square root of 7 units. 2 times 2 is 4. So in conclusion, we found out that X equals to 4 over square root of 7 units, or in terms of numbers, it is equal to 1.51 units. Okay, so here remind you that x equals to either 4 over the square root of 7 units, or in terms of numbers it is equal to 1.51 units. In the next step I will summarize the lecture, and we'll start with the first question. So here in the drawing we have square ABCD. We know that the radius of the circle is equal to 2 units. We know that line segment D equals to 1 unit. And we want to find out the length of one side of square ABCD. Okay? So actually we defined the center of this circle as point O. We define the point of tendency of tangent AD with this circle as point M. We join points O and M together by a straight line. The definition of line segment OM is the radius of this circle. Why? Because it starts from the center of the circle and ends at point M, that is the point of the circle itself. This is exactly the definition of a radius. So OM is the radius of this circle that is equal to 2 units according to what is given us the question. So here the radius OM, it is drawn to the point of tendency, that is to say it is drawn to point M, that is the point of tendency of tangent AD with this circle. And whenever you have a radius that is drawn to the point of tendency, then the tangent AB will be perpendicular to the radius MO. Again, AD is perpendicular to MO, that is to say this angle equals to 90 degrees and this angle will be also equal to 90 degrees. Okay, likewise from the center we define the point of tendency of tangent AB with this circle as L. Then we join points O and N together by a straight line. OL is the radius of this circle. Why? Because O is the center of the circle and N is the point on the circle itself. This is exactly the definition of a radius. Therefore, OL equals to the radius of this circle that is equal to 2 according to what is given as the question. So here we have the radius OL that is drawn to the point of tendency, that is to say the radius OL, it is drawn to point N, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is drawn to the point of tendency, then the tangent AB will be perpendicular to the radius LO. So if AB is perpendicular to LO, it means that this angle equals to 90 degrees and this angle will also equal to 90 degrees. It is given as the question that ABCD is a square. Therefore, and we know that all the angles inside the square are right angles, that is to say angle DAB is a right angle. So actually we found out that in quadrilateral OAM AL we have 1, 2, 3 right angles. Okay, in quadrilateral MOAL we have 3 right angles, and the sum of 3 right angles is 90 times 3 is 270 degrees, plus the size of the fourth angle that is actually angle MOL. In total, the sum of those 4 angles must be equal to 360 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. We subtracted 270 degrees from this equation and found out that the missing angle MOL equals to 360 degrees minus 270 degrees, it is equal to 90 degrees. So the fourth angle MON here equals to 90 degrees. So actually we found out that all the angles inside quadrilateral MOAL are right angles. And any quadrilateral that has 4 right angles must be at least a rectangle. So we relate to quadrilateral MOAL as a rectangle. And we know that the opposite sides of a rectangle are equal to each other. That is to say, in rectangle MOAL, its opposite sides, they are equal to each other. That is to say MO equals to AL. MO equals to AL, but we have already found out that MO equals to 2. So we can write here that MO equals to 2. And from this equation 2 equals to MO equals to AL, we derive that AL is also equals to 2 units. Likewise, according to the rule that the opposite sides of a rectangle are equal to each other, we will AM is equal to OL. Okay, in a rectangle MOAL, AM must be equal to OL. Here, AM must be equal to OL. But we have already found out that OL equals to 2 units. This is the radius of the circle. We can write here that O equals to 2 units. So from this equation 2 equals to OL equals to MA, we will derive that MA is also equals to 2 units. So here, MA is also equals to 2 units. So we found out actually all the 4 sides of quadrilateral MOAL, they are equal to each other, they are equal to 2 units. Therefore, quadrilateral MOAL is not a rectangle but a square. Okay? Then we defined one side of square ABCD as x. That is to say, AB equals to BC equals to CD equals to AD equals to x, according to our definition. Then I presented to you rule number 2 that I have already mentioned in the past, that the lengths of two tangents from a common external point to a circle are equal. So then we focus at point E. Point E is the common external point in relation to this circle, and from the common external point, point E, we have two tangents to this circle. The first tangent is tangent EM, and the second tangent is tangent EH. And according to rule number 2 that I mentioned to you, the lengths of those two tangents that are exiting from the common external point, point E, must be equal to each other. That is to say, EM equals to EH. According to rule number 2, EM must be equal to EH. And what is the length of EM? The length of EM, it is equal to AD minus DE minus MA. Okay? Here, EM equals to AD minus DE minus MA. That is to say, EM equals to AD, that is x, minus DE, that is 1, according to what is given as the question. And we already found out that MA equals to 2. So in conclusion, we found out that EM equals to x minus 1 minus 2, x minus 1 minus 2 equals to x minus 3. So in conclusion, we found out that EM equals to x minus 3. So EM equals to x minus 3. So according to rule number 2, we have already found out that EM equals to EH. But we just right now found out that EM equals also to x minus 3. So from this equation, x minus 3 equals to EM equals to EH, we derive that EH is also equals to x minus 3. EH is also equals to x minus 3. Then we focused on the right, at point B. We focus on point B. Here, we focus on this point, point B, the common external point, point B. From the common external point, point B, we have two tangents to the circle. The first tangent is tangent BL, and the second tangent is tangent BH. And according to rule number 2, BL must be equal to BH. And then again, at point B, BL must be equal to BH according to rule number 2. What is the length of BL? It is very easy to see from the drawing that BL equals to to AB minus AL. Again, AB minus AL equals to LB. Okay. Yeah. BL equals to AB minus AL. So BL equals to AB, that is X, minus AL, that is equal to 2 units. So in conclusion, found out that BL equals to X minus 2. Okay, so from one side BL equals to BH. From the other side, we just right now found out that BL equals to X minus 2. So we can add here that BL equals to X minus 2, and from this equation X minus 2 equals to BL equals to BH, we will derive that BH is also equals to X minus 2. So here BH is also equals to X minus 2. Then we focused on the right triangle, triangle EAB, and we implemented the Pythagoras theorem on this right triangle, triangle EAB. But first of all, we found out the length of side EA. For the drawing, you can see it is very easy to see that AE or EA equals to AD minus DE. Again, AD minus DE equals to AE. Okay, here A equals to AD minus DE. So A equals to AD, that is X according to our definition, minus DE, that is 1 according to what is given as the question. So in conclusion, we found out that A equals to X minus 1. And we know that AB equals to X according to our definition. And the hypotenuse DB equals to X minus 3 plus X minus 2. Here, the hypotenuse B equals to X minus 3 plus X minus 2. X plus X is 2X. And minus 3 plus minus 2 is minus 5. So in conclusion, we found out that the hypotenuse EB equals to 2x minus 5. Then we implemented the Pythagoras theorem on this right triangle, triangle EAB. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So EB square equals to AE square plus AB square. We substitute BE by 2x minus 5, AE by x minus 1, and AB by x. When you got this equation, we open the brackets on both sides of the equation, and we found out that 2x minus 5 equals to 2x squared, that is 4x squared, plus 5 squared, that is 25, minus 2 times 2x times 5, that is minus 20x, and this is equal to x minus 1 squared, that is x squared, plus 1 squared, that is 1, minus 2x, plus x squared. Okay, then actually add. So in this side of the equation we have 4x squared minus 25 minus 20x, and here x squared plus x squared is 2x squared minus 2x plus 1. So here we got this equation, and here we subtracted 2x squared from this equation, equation number 1. 4x squared minus 2x squared is 2x squared. Here we have 25, and the other side we have, of the equation we have 1. So we subtracted also 1 from equation number 1. 25 minus 1 is 24, and 1 minus 1 is 0. And here we have minus 20x in this side of the equation, and the other side of the equation minus 2x. So we added 2x to this equation, equation number 1, and we got that minus 20x plus 2x is minus 18x. And 2x minus 2x is 0. So in conclusion, we found out that 2x squared plus 24 minus 18x equals to 0. We divided this equation, equation number 1 by 2, and we got that x squared minus 9x plus 18 plus 12 equals to 0. Here we have the quadratic equation, x squared minus 9x plus 12 equals to 0, the coefficient a equals to 1, the coefficient b equals to minus 9, and the coefficient c equals to 12. And the general formula for solving out the quadratic equation is x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. So here x will be equal to minus b equals to minus 9, so minus b is minus 9, that is plus 9, plus minus square root of b squared. B is 9, so b squared is minus, b is minus 9, so b squared is minus 9 squared, that is 81. Minus 4 times a is 1, times c is 12. So it is minus 4 times 12, over 2a. A is 1, so 2 times 1 is 2. Then we got that x equals to 9 plus minus 81, and minus 4 times 12 is minus 48 over 2, so x equals to 9 plus minus 81 minus 48 is 33, so inside the root we left only with 33 over 2. So here we have two solutions that are possible for x. The first solution for x is that x equals to 9 minus square root of 33 over 2, that is actually 1.62 units. But in the drawing, according to our definition, AB equals to x. AB equals to x according to our definition. So x is greater than AL. Here, this is x, and you can see from the drawing that x is greater than AL, that is 2. That is to say, x must be greater than 2 units. Okay? X must be greater than 2 units. But 1.62 is less than 2 units. Therefore, this solution is incorrect solution. We cancel this solution. And we left only with the second solution. That is x equals to 9 plus minus x equals to 9 plus square root of 33 units over 2. That is in terms of numbers, it is equal to 7.37 units. So we found out here that x, the one side of square ABCD, equals to about 7.37 units, or we can present it also as 9 plus square root of 33 over 2 units. We finished with the first question. Then I'll present to you how we found, how we answered to the second question according to the first method. So here we have triangle ABC. We know that BD equals to 2, this angle equals to 60 degrees, this angle equals to 60 degrees, AB equals to A, AC equals to 2A, and we want to find out the length of side AD that is equal to x. So first of all, I presented to you the angle bisector theorem. According to angle bisector theorem, in any triangle, here triangle ABC could be any triangle. In triangle ABC, we have the angle bisector AD. Why AD is angle bisector? Because of the fact that it bisects angle BAC into 2 halves. Each half equals to theta. So we have here the angle bisector AD. Therefore, we can implement the angle bisector theorem here. According to angle bisector theorem, AB over AC equals to BD over DC. Okay? Implemented the angle bisector theorem in triangle ABC. In triangle ABC, we have the angle bisector AD, therefore AB over AC will be equal to BD over DC. AB over AC equals to BD over DC. AB equals to A, AC equals to 2A, according to what is given as the question. BD equals to 2, and DC is the missing line segment. A over A is 1, so A will get cancelled, and we left only with 1 half, that is equal to 2 over DC. Because multiply this equation, equation number 1, and found out that DC equals to 2 times 2. 2 times 2 is 4, so we found out that DC equals to 4 units. Then we made the construction. We extended the straight line. We extended side AC by a straight line, and then from point D we drew perpendicular on the extended AC. Again, from point D we drew perpendicular on the extended line segment AC. So this angle equals to 90 degrees according to our construction. We define the touching point of the extended line segment CA, and the perpendicular from point B is E. Okay? And then we focused, so here we extended the straight line CA by straight line, therefore the result must be a straight line. So CE, when you extend a straight line by straight line, the result must be a straight line. Therefore, CE is a straight line. Here, CE is a straight line. And we have the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on this side of the straight line EC at point A, then the sum of the angles here must be equal to 180 degrees. So which angles we have at this side at EC at point A? We have 60 degrees plus 60 degrees plus angle BAE. In total, the sum of those three angles must be equal to 60 degrees. So 60 degrees plus 60 degrees plus angle EAB must be equal to 180 degrees according to the rule that I mentioned. 60 degrees plus 60 degrees is 120 degrees. So we subtracted 120 degrees from this equation and found out that the missing angle, this angle, equals to 60 degrees. So in the green triangle EAB, the green right triangle EAB, we know that cosine 60 degrees equals to EA over AB. EA over AB. So it is EA over AB, but AB equals to A according to what is given as the question. So cosine 60 degrees equals to EA over A. We substitute AB by A, and then we multiplied this equation by A, and we got that EA equals to A times cosine 60 degrees, and cosine 60 degrees equals to 1/2. So we substitute cosine 60 degrees by 1/2, and we got that EA equals to A over 2. So here EA equals to A over 2. Then here sine 60 degrees equals to EB over AB. Sine 60 degrees equals to EB over AB. Sine 60 degrees equals to square root of 3 over 2. And this is equal to EB over AB. AB equals to A, so we substitute AB by A. And we got that square root of 3 over 2 equals to EB over A. We multiplied this equation by A, and we found out that EB equals to square root of 3 over 2 times A. EB equals to square root of 3 over 2 times A. Okay, then I copied the right triangle EBC in a new page, and we implemented the Pythagoras theorem on the right triangle, triangle ABC. In this right triangle, triangle ABC, BC squared equals to EB squared plus EC squared. Okay, so here BC equals to 6, so BC squared is 6 squared, it is 36. B equals to square root of 3 over 2 times A, so B squared equals to square root of 3 over 2 times A squared. EC equals to 5 over 2 times A, so EC squared will be equal to 5 over 2 times A squared. We open the brackets on this side of equation number 2, and we found out that 36 equals to square root of 3 over 2 times A is 3/4 times A squared, and plus 5 over 2 times A squared is 25 over 4 A squared. 3 quarters times A squared plus 25 quarters times A squared equals to 28 quarters times A squared, that is 36. We divided 28 over 4 is 7, so 36 equals to 7A squared. We divided this equation by 7 and found out that A squared equals to 36 over 7. We took out of this equation, equation number 2, and found out that A equals to 6 over square root of 7 units. Then I presented to you a new way to calculate the area of any triangle. Actually, we have here rule number 3 that is related to angle bisector theorem. In this triangle, triangle ABC, that could be any triangle, we have the angle bisector AD. Therefore, we can use rule number 3. According to rule number 3, AD squared equals to AB times AC minus BD times DC. We can implement rule number 3 in triangle ABC because triangle ABC have the angle bisector AD. This is triangle ABC that I copied from the original drawing. According to rule number 3, we get that AD squared equals to AB times AC minus BD times DC. AD equals to X, so AD squared is X squared. AB equals to A and AC equals to 2A. BD equals to 2, DC equals to 4. So minus 4 times 2 is minus 8. So X squared equals to 8 times 2A squared minus 8. Then we substitute A squared by 36 over 7, and we got that X squared equals to 2 times 36, that is 72, minus 8. We multiplied 8 by 7, we divided by 7, and we got that X squared equals to 72 minus 56 is 16 over 7. So we found out that X equals to X squared equals to 16 over 7. Then we took out of this equation and we found out that X equals to 4 over square root of 7 units, or in terms of numbers it is 1.51 units. Then I presented to you how to find out the length of line segment X according to the second method. In the second method, we define angle. This angle is theta, therefore this angle must be equal to 180 degrees minus theta. Then I presented to you the law of sines. According to the law of sines, here A over sinus A equals to B over sinus B equals to C over sinus C. We implemented the law of sines in triangle DAB. In triangle DAB, we get that A over sinus theta equals to 2 over sinus 60 degrees. We implemented the law of sines also in triangle ADC. In triangle ADC, we get that CD over sinus 60 degrees equals to 2A over sinus 180 degrees minus theta. And we have the trigonometric identity that sinus 80 degrees minus theta equals to sinus theta. So we can substitute sinus 80 degrees minus theta by sinus theta. We did it. And we got that according to equation number 2, CD over sinus 60 degrees equals to 2A over sinus theta. Okay, here, according to equation number 1, A over sinus theta equals to 2 over sinus 60 degrees. So we can substitute A over sinus theta by 2 over sinus 60 degrees. We did it, and we got that CD over sinus 60 degrees equals to 2 times 2 over sinus 60 degrees. We have sinus 60 degrees on both sides of the equation, so sinus 60 degrees will get cancelled, and we're left with CD that is equal to 2 times 2, that is to say CD equals to 4. So we found out that CD equals to 4, then I presented to you the law of cosines. According to the law of cosines, here in any triangle, cosine theta equals to A squared plus B squared minus C squared minus 2 times A times B. We implemented the law of cosines in this triangle ABC. And in this triangle ABC, we get that according to the implementation of the law of cosines in this triangle ABC means that cosine 120 degrees will be equal to A squared plus 2A squared, that is 4A squared, minus 6 squared, that is 36, over 2 times A times 2A. And cosine 120 degrees equals to minus 1 over 2. Here, A squared plus 4A squared is 5A squared, minus 36, over 2A times 2A. We have cosine 120 degrees equals to minus 1 over 2. So we have 2 on both sides of the equation. 2 will get cancelled, and then we cross multiplied this equation, and we got that minus 2A squared equals to 5A squared plus 36. We added 36, and we also added 2A squared to this equation, and found out that according to equation number 3, we actually have 7A squared equals to 36. Here we divided this equation number 3 by 7 and found out that A squared equals to 36 over 7. We took out of this equation and found out that A equals to 6 over square root of 7 units. Okay, then I presented to you a new way to find out the area of any triangle. In this triangle, the area of this triangle ABC, equals to A times B times sinus theta over 2. Implemented the new rule to find out the area of the triangle in triangle ABC. And then here, in this triangle ABC, you know that the area of triangle ABC equals to the area of triangle ABD plus the area of triangle ADC. Okay? The area of triangle ABC equals to the area of triangle ABD plus the area of triangle ADC. The area of triangle ABC, according to the new formula that I presented to you, will be equal to A times 2A times sine 120 degrees over 2. A times 2A times sine 120 degrees over 2. The area of triangle ADB equals to A times X times sine 60 degrees over 2. Here it is A times X times sine 60 degrees over 2. And the area of triangle ADC, this triangle ADC equals to X times 2A over sine 60 degrees over 2. X times 2A over sine 60 degrees over 2. Here sinus 120 degrees equals to sinus 60 degrees, so we can divide the equation by sinus 60 degrees, so sinus 60 degrees will be cancelled, and also sinus 120 degrees. We have 2 on both sides of the equation, so 2 will also get cancelled, and we have A on both sides of the equation, so A will also get cancelled. After we cancelled all those variables, we left only with 2A that is equal to X plus 2A. So 2A equals to X plus 2X. X plus 2X is 3X, so we found out that 2A equals to 3X. We divided this equation by 3, and we got that X equals to 2 over 3 times A. But we already found out that A equals to 6 over square root of 7 units, so we can substitute A by 6 over square root of 7 units. We did it, and we got that X equals to 2 over 3 times 6 over square root of 7 units. Here 6 over 3 is 2, and 2 times 2 is 4. So in conclusion, we found out that the area, the length of side AD that is equal to X, according to the second method, it is equal to either 4 over square root of 7 units, or in terms of numbers, it is equal to 1.51 units. Okay, I'll repeat again. The area, the length of line segment AD that is equal to X, according to the second method, it is equal to 4 over square root of 7 units, or in terms of numbers, it is equal to 1.51 units. Okay, so in both methods, we arrive to the same answer for X. Okay, thank you very much.